Hello, I'm going to do a problem out of section 7.2, which deals with creating confidence intervals for proportions. So this is number 32 on page 355. An important issue facing Americans is the large number of medical malpractice lawsuits and the expenses that they generate. In a study of 1,228 randomly selected medical malpractice lawsuits, it's found that 856 of them were later dropped or dismissed. A, what's the best point estimate of the proportion that are dropped or dismissed? And then B, construct a 99% confidence interval for that proportion. So the point estimate is just going to be p hat. Our best point estimate for the true proportion is p hat, which is 856 over 1228. If you do a decimal approximation, that's approximately equal to 0.6971. You want to round that to 4 places. Don't just round that to 0.7 or something like that. So B, to get a confidence interval, because we have at least 5 successes and failures, most books use 5 as that cutoff. Sometimes people use 10, but we have at least 5 successes and failures, so we're able to do this. We have p hat plus or minus a z critical value times standard error is this thing, it's p hat times 1 minus p hat divided by n. So it's going to be 0.6971 here, here, and here. 1228 is n. So all we need is this z critical value off the table. So let's go ahead. I've got it queued up, the table that you guys have in your book. It'll take a second for the camera to come on. Okay, so what you'll notice, if you go to the top here, is we have 2 different headings. The area in one tail and the area in 2 tails. When you do a confidence interval like the one that we're doing, we want the middle 99% to be our cutoffs. So we want the area in 2 tails, since it's a 99% confidence interval, we want the area in the 2 tails on the outside. A good picture of this is just down here on the right. The area in these 2 tails together, since we want 99% in the middle, we want 0.005 here, 0.005 here, which is a total of 1%. So for area in 2 tails, if you do a 99% confidence interval, you just take the 100 minus 99, you get 1%. So we want 1% out here in the 2 tails. So area in 2 tails, we want to be 1%. So we're going to use this leftmost column. And if we scroll down, we've got a bunch of t critical values, which we're not going to use in this particular case. And then we've got 2.576. So the bottom row right here corresponds to the z critical values. This would be 99. The middle one is 95. This is 90 and 80. I think this is 98 if I scroll up. But basically, the different columns correspond to the confidence levels, and the bottom row corresponds to z ones. When you do t-based confidence intervals, you're going to use these ones above. So 2.576 is what we want. So I'll write 2.576 here. And I've done the calculations ahead of time on my calculator, if I did them correctly. We end up with a confidence interval. The left endpoint is 0.6633. And the right endpoint is 7308. Okay? So we're 99% confidence between approximately 66% all the way up to 73%. If we do part C, the follow-up question, it says, does it appear the majority of such suits are dropped or dismissed? Well, because our confidence interval is entirely above, we look at the number line, it goes between 0 and 1. If this is a half, remember majority means above a half. If our interval is from here to here, our interval is entirely above a half. So yes, because this interval is entirely above a half, we can conclude that the majority have been dropped or dismissed. So that's this problem, and look for me to continue to do some more. Thanks.